In this video, we're going to be looking at how to use the elimination method when solving simultaneous equations. So in another video of mine, we looked at how to use the substitution method, and that involved rearranging one variable in terms of another. But let's have a look at an example like this, where we have two equations where we can easily isolate for the x variable here. So what I'm able to do is I'm able to give each of these equations a number. So the first one is equation 1 and the second one is equation 2. And what I'm simply going to do is I'm going to find a way to simply eliminate the x variable. Hence, this process is known as elimination. So I'm going to find a way to get x and x to cancel, and the way I'm going to do that is by doing equation 1 minus equation 2. So what that means is I'm going to take everything on the left-hand side for equation 1 and minus it with everything on the left-hand side of equation 2. So if I were to do that, it would be x minus 2y for equation 1. And then for equation 2, it would be minus x and minus 6y. And whatever I do to the left-hand side, I must repeat to the right-hand side. So I'm going to do equation 1, which would be equal to 6, minus equation 2, which is equal to 10, so minus 10. So now what I can do is I can combine my variables and combine my constants. So x minus x, that's what eliminates. That was the whole purpose of this entire process, was to eliminate the x away. So then what I have is minus 2y minus 6y, which is minus 8y. And that equals to minus 4. And if I simply solve for y is equal to minus 4 on minus 8, or simply a half. Now, if I wanted to work out what the value of x would be, what I can simply do is substitute this value for y back in to either equation 1 or into equation 2. And that's exactly what I'm going to do. I'm going to substitute it back into equation 1. So I know that x minus 2y equals to 6, and I just worked out that y was a half. So x minus 2 times a half is equal to 6, and that simply means that x minus 1 equals 6, or x equals 5. So my solution for this simultaneous equation is x equals to a half and x equals to 5. Try and verify this solution using the substitution method as well. Now let's have a look at another example where we have two equations in the same way as before and we're trying to eliminate a variable. It doesn't matter which variable you eliminate or by what method you use to eliminate them, but I would always recommend, if you see the same variable on both the first equation and the second equation, including the signs, so it's positive y here and positive y here, I'd recommend eliminating that variable. So once again, I'm going to give the first equation, equation 1, and the second equation, equation 2. And so in order for me to eliminate the y's, I can simply do the y from the first equation minus the y from the second one. So that becomes equation 1 minus equation 2. And so I have to repeat the same steps now. Everything on the left-hand side is minused away from each other, and the same thing happens on the right-hand side. So my equation will become y minus x minus y equals to 5 minus 3. I can see that y minus y simply cancel each other out, so they have been eliminated. And then minus x is minus 2x, and that simply equals to minus 2, which means that x equals to 1. Now if I wanted to work out the value for y, I simply input this value back into either equation 1 or into equation 2. I'm going to choose to do equation 2 because it's simpler in this case. So x plus y equals to 3, and that means 1 plus y equals 3, and hence 1 equals to 2. So those are my solutions for this example here. Now let's say we have an example like this, where we can't clearly eliminate a single variable very nicely. We have 2x on the top, but we have the minus 3x on the bottom, and we don't even have the variables on the same side. So in this case, I would highly recommend using substitution because you can easily substitute this part for y in the first equation, but in case you wanted to learn how to do elimination, this is how you would do it. So I notice that I have a y on the left-hand side here and a y on the left-hand side here. So I'm going to try and eliminate just that variable. However, if I try doing equation 1 minus equation 2, what I'll end up with is minus 3y minus y. And that equals minus 4y, which is not what we want. We want 0. And I can't even do equation 2 minus equation 1, because if I try doing that, I'll have y minus minus 3y, which is just positive 4y, which again, we want 0. So what I'm going to do in this case is I'm going to times everything in the second equation by a scale factor of 3. I'm going to times all the values there. So now what I'll end up having is 3y equals to 15 minus 9x. So that's like my equation 2 modified. I'm just going to do 2 prime there to show that it's still equation 2, but just slightly modified. And now if you notice what I can do, I can say that minus 3y from equation 1 plus 3y from equation 2 prime, well, that's equal to 0. So the operation I can do is equation 1 plus equation 2 prime. And so the same steps occur. I have to do everything additioned on the right hand side and the same on the left hand side. So 2x take 3y plus 3y equals to 7 plus 15 take 9x. And now if I were to simplify this out, I can see I have eliminated my y because they no longer exist. I'm just left with x. And if I move this minus 9x to the other side by doing plus 9x, I have 2x plus 9x. And 2x plus 9x is 11x. And that simply equals to 7 plus 15. And 7 plus 15 is 22. And that means x equals to 2. Now what happens if I want to solve for y? Well, it's the same steps. I'm just going to substitute it back into equation 2 in this time, because I can easily get out a y value for an input of x. So y equals to 5 minus 3x. That means that y equals to 5 minus 3 times 2, and that means y equals to 5 minus 6, which means y equals minus 1. So that's how you solve it for an ambiguous case like this where it's not easy to eliminate. Now this is the last example I'll be doing in this video, but I want you to have a go at it first. Pause the video and see how you would solve the simultaneous equation using the elimination method. Don't use substitution for this case, just so we get some practice. Have a go. Okay, so now I'm going to do the exact same thing. I'm going to find which variable is going to be easier to eliminate, and in this case it doesn't look very easy to eliminate either one. So simply to get the lowest common multiple between 4x and minus 5x, I can times the first equation by 5 and times the second one by 4. That way I'll have 20x in the first equation and minus 20x on the second one. But what I can also do is I can get the lowest common multiple between minus 3 and 4, which in that case I'd times the first equation by 4 and the second equation by 3. So we did an example before where we just times one equation by a constant, but this time we're going to do both. And for this example, I'm just going to eliminate the variable x. So what I'm going to do is I'm going to say this is equation 1, this is equation 2, but what I'm going to do is if I want to eliminate x, I need to find the lowest common multiple between 4x and 5x. And so the way I do that is I times this equation by 5 and I times this equation by 4. And so what I'll have is, for the first equation, I'll have 20x minus 15y equals to 5. And for the second one, I'll have 16y minus 20x equals to 8. So this is my 1 prime, this is my 2 prime. Now I can try and eliminate my x's. So I can see that 20x plus minus 20x is going to equal to 0. So I'm simply going to do the operation 1 prime plus 2 prime. And so what I have left is this. I have 20x minus 15y minus plus 16y minus 20x equals to 5 plus 8. And you can clearly see that 20x and minus 20x eliminate itself, and I'm left with just y. So y equals to 5 plus 8, and that is simply 13. So that is my solution for y. And if I want to find the solution for x, it's the same steps. Just sub it back into either equation 1 or equation 2. And for this one, I'll just simply sub it into equation 1, but it doesn't matter which one you do. So I have 4x minus 3 times 13 equals to 1. 4x minus 39 equals to 1. 4x equals to 40, and that means x equals 10. And that's how you do elimination with simultaneous equations.